Hey everyone, we're going to talk about Pythagorean theorem, special right triangles, and then actually talk about areas of triangles at the end of the unit. I kind of want to rehash and go over everything for special right triangles and Pythagorean theorem again for the test. So let's get going on this here as we go through. First, for the warm-up, we worked on this yesterday, trying to determine whether triangles were triangles. Take a few minutes to kind of go through these, make sure that they classify them as triangles or not, and then come back and we'll kind of go through it. All right, so if we remember from yesterday, what we do for triangles is we take the two smallest sides, in this instance 4 and 5, add them together. That's 9. Compare the 9 to 8, it's bigger, so number 1 is a triangle. 2, we take the two smallest sides, again we're looking at 13 and 4, that's 17. That is not greater than 18, so this is not a triangle. No. Same thing, two small sides here, 3 and 11 is 14. It's not bigger than 15. No. Two small sides are 8.5 and 14. That's 22.5. Bigger than 17, so this is yes, it's a triangle. Hope that makes sense. Hope everybody kind of remember that from yesterday. Like I said, on the test, you're going to be given 3 side lengths. You're going to have to tell me that they're a triangle, and then you're going to have to use the Pythagorean theorem rules that we're going to talk about again today to classify them as acute, obtuse, or right triangles. Okay. Pythagorean theorem. If we remember Pythagorean theorem, it's a squared plus b squared equals c squared. We can use that in any right triangle to find the value of a missing side or to confirm that it is a right triangle or not. Here we're trying to find x. So we're told x is the opposite of these sides. A squared plus b squared equals c squared. So it's 13 squared plus 23 squared is going to equal x squared. Grab my calculator really quickly, plug those numbers in. 13 squared is 169. 23 squared is 529, so I get 169 plus 529 equals x squared. So if I try to take the square root of that, 169 plus 529, we're looking at the square root of 698, which works out to actually be, x is going to be 26.42, let's say. Well, you could have kind of factored that out, tried to get a good factoring on that. I'm just going to go with letting you take the square roots of them for now on these stuff, because there's some big numbers and it's really weird and I don't want to confuse you on all that. Same thing here, we have 34 squared is our c. That's going to equal x squared plus 21 squared. So we kind of look at that. 34 squared is 1156. 21 squared, I believe, is 4441, or 441 plus x squared. Subtract 441 from both sides. We end up with 715 equals x squared. Again, we'll just take the square root of that, simplify and save time. This is going to be 26.74. And the last one, we got one side is 18, which actually is half of it, so it's 9. So 9 squared plus x squared is 26 squared. So 81 plus x squared is going to equal 676. We subtract 81 from both sides of there. I end up with x squared equals 595. Again, we'll just take a square root of that, which is 24.39. So again, that was pretty simple. I think we all remember that. What I'm going to do is there's some problems next for you to work through. I'll post an answer sheet out on Classroom so you can check your answers on your work. And then just kind of go through and have your answers in Edpuzzle as you go through. So those 3 problems you can work on your own. Again, those ones well. It's just pretty much all today is going to be is just kind of doing a lot of Pythagorean theorem work and review, just to make sure you know what it is. Yeah, we'll check your answers online. when you're done. The rules for classifying triangles, though, I want to kind of go over those. Remember, it's still a squared plus b squared. A squared plus b squared equals c squared. That tells me I have a right triangle. If that statement is true, it's a right triangle. Whoops, E at the end. We have two other versions. We have a squared plus b squared is greater than c squared, and a squared plus b squared is less than c squared. And they're going to tie us to either obtuse or acute right triangles. So try to take a minute, kind of think back and say which one's which. Okay, so when we kind of look at it, a squared plus b squared equals, or is less than, sorry, is greater than a squared or c squared. This is our obtuse triangle. Because my sides of my triangle are much bigger when I square them than the hypotenuse side, which is always the side opposite that C angle. And then that makes this one our acute triangle. Does that make sense? Okay. So we're going to move on. We're going to kind of classify some stuff. I think we got some problems to work on. Yep. So this is like what we're going to have on the test. Determine if they're triangles. So we're going to take the two shortest sides. 10 plus 11, 21. Yes, it's a triangle. Now we need to figure out, is it an acute triangle or is it an obtuse triangle? So now we go, I know this is my hypotenuse, so this is C now. So 10 squared plus 11 squared equals 20 squared. So I got 100 plus 121 equals 400, not 400 squared, equals 400. So it's actually less than. So that's less than 400. So I kind of have to remember, and we're going to double check to make sure I'm telling you the right thing, because I'm afraid that I just misspoke and we'll have to re-record the video. So yes, I think I actually had that right. Sorry about the problems. So c squared, when c squared is less than a squared plus b squared, it's acute. So this now is an obtuse triangle. Sorry about that. I just want to double check, make sure I told you the right stuff. So when c squared is greater than a squared plus b squared, you're looking at an obtuse triangle. Again, we're kind of looking, we have 12 plus 14 does not anywhere come close to 49. So this is not a triangle. This is not a triangle. We don't have to classify it. Oh, here's a tricky one. 5 squared root 2 plus 10 is, or 11. So I'm trying to think, I think 5 squared root 2 is probably less than 10. This one might be one you have to go through and classify and determine, but I'm going to tell you that this is a triangle. So now I get a squared plus b squared equals c squared. So I got 5 square roots of 2 squared plus 10 squared equals 11 squared. I always do 11. I always do equals, sorry, even though I know I'm trying to figure out it might be greater than or less than, but I always start with equals. 5 square root of 2 squared is 5 times, so we square 5, we square the square root of 2. So 5 squared is 25, square root of 2 squared is 2. So 25 times 2 becomes 50. 10 squared is 100. 11 squared is 121. So I end up with, this is greater than, again, when c squared is less than a squared plus b squared, this is acute. That makes sense. I know I kind of worked through the problem yourself, or worked through the problem on my own there, quickly through the 5 squared root of 2 squared. Hope everybody saw that. Take a few minutes and try 14, 15, and 16. Again, put your answers in that puzzle, but then double check on the thing I'm going to post to Google Classroom with the answers on that. It'll be kind of this video, this presentation with all the answers in that. It'll be later in the day, tomorrow, or on Tuesday, sorry. Okay, word problem. Pythagorean theorem word problem. The bottom end of a ramp is 10 feet from the base of a main dock and 11 feet long. How high is the dock? So we kind of just draw it in. It definitely looks like a right triangle. It's a right triangle section. We're going to assume it's a right triangle. We have to figure out how high the dock is. So now we're looking for the question mark, and we're going to call it x. So again, we go right into it. 11 squared equals 10 squared plus x squared. We got 121 equals 100 plus x squared. Subtract 100 from both sides. I end up with x squared equals 21. What an ugly number to take the square root of. The best part is we just take the square root of it. So you can leave it as radical 21, square root of 21, or if you want to do the math, figure it out on a calculator. It's going to be somewhere between 4 and 5. 4.58 to be exact. So either one of those would be good for an answer on a test. There will be a word problem on the test with Pythagorean theorem. Next question. This is a little bit trickier when we kind of look at it. Construction workers are building a marble sidewalk around a park that is shaped like a right triangle. Each marble slab adds 2 feet to the length of the sidewalk. And that might be important. I'm going to underline it. The workers find that exactly 1,071 and 1,840 slabs are required to make the sidewalks along the 2 shorter sides of the park. How many slabs are required to make the sidewalk that runs along the long side of the park? So I'm going to draw my park. Look, my park's a right triangle. The only thing they're telling me is the slabs are going to add 2 feet to the length of the sidewalk. So basically, the sidewalk kind of goes out 2 feet on each side, but what the part of that we really don't need to worry about is a squared plus b squared equals c squared doesn't just represent distance. They tell me that one side, let's just call it, is 1,071 slabs. The other side is 1,840 slabs. I'm trying to figure out how many slabs I need for the long side of the park. So again, unfortunately, 1,071 squared plus 1,840 squared equals x squared. I'm going to save you the trouble. You can work through that to double check my math. I'm just going to tell you right away. X equals 2,129. It actually does work out. It is a perfect right triangle. Does that make sense word problem wise? Doesn't always have to be distance. We can give you other objects to kind of fill in. Because when you think of it, if we kind of drew out our sidewalk here, actually I'm going to kind of extend it in a different color. If I extend this out kind of in blue, so here's my sidewalk on this side, right? They're telling me that there's 1,800, like if I kind of draw in little tiles, is what they're talking about the slabs. So there's 1,800 slabs there, there's 1,071 slabs on the other side. It still works out. Okay, special right triangles. Let's remember the generic form of the 2 special right triangles. 45, 45, 90. These are my 45 angles. So if we remember the generic term of that, the 2 legs are x. The hypotenuse is x times the square root of 2. So no matter what side they tell us, we can figure out the other side. If they tell us the leg is 15, hypotenuse is 15 square root of 2. We can work backwards. If they told us the hypotenuse was 24, we do the math to work backwards, which I'll show you again. We end up getting the legs are each 12 square roots of 2. Then we also had the 30, 60, 90 triangle. That's 60. This is 30. That's my right angle. We learned today, or we learned yesterday actually, the smallest angles opposite the shortest side, we're going to call the short side x. We remember that the hypotenuse of a 30, 60, 90 triangle is 2x. The long leg is x squared root of 3. So again, we have our general terms. No matter what side they tell us, we can back into what the other sides are. Does that make sense? Okay, let's do an example, and then you guys can work on the problems that are also there. I'll do 1 and 2. We'll leave you the rest of them. So they tell us that the leg is 14. I know this side here should be the hypotenuse from the general term is x squared root of 2. So x is 14. So my hypotenuse then, the x value here, what they're looking for, is 14 times the square root of 2. I understand the confusion about trying to find x when we have x in our answer. Just know that we just wanted that side length, not that we actually have multiple x's there. So the hypotenuse of this triangle is 14 square root of 2. Here they're telling me my hypotenuse is 45 units. I'm trying to find the legs. Again, our general form, this here x, this usually x squared root of 2. So I can solve that equation. X squared root of 2 equals 45. So I multiply both sides, or sorry, divide both sides by the square root of 2. That leaves me with x equals 45 over the square root of 2. If we remember, we talked about having to rationalize that denominator, which is multiplying both the top and bottom by the square root of 2 over square root of 2. That leaves me with 45 times the square root of 2 over 2. I'm just going to leave it like that. You can leave rationalized numbers like this. We can leave them as fractions. So x actually equals 45 times the square root of 2 over 2. If you want to simplify it, 22.5. Square root of 2, that's fine, but you don't have to. Okay, so you try the rest of those. There's problem 3 on this screen. There are 3 more on the next screen. Again, the video will be posted. The video will be posted, but then the PowerPoint presentation will be posted with all the right answers so you can check your work after you do it. Here's the 30, 60, 90. I'll kind of run through one of these with you to go from there. Again, they've given you the short side is the opposite side of the 30-degree angle. That's 9, so x is 9. You can basically plug in with our general form for the rest of them. I'm going to show you number 8 as an example because they've given me my hypotenuse side is 4 square roots of 3, so I remember this side is the 2x side. This is going to be, I'm going to call it S for this example as we work through it, okay? So I'm not using same variable in what I'm trying to solve for. So we're going to call this side 2S. That makes this side S. Whoops, again, I'll erase that too. I'm having trouble today. So we'll erase that. We're going to make this side S. This side is S square root of 3 in the general form of our problem. The 2S side, so 2S equals 4. I'm going to do square root of 3 times 4. Do it all backwards. Now it's really messy, so now I'll erase it and give you better stuff. These high quality videos I put up for you guys. All right, so we're going to divide both sides by 2 to find my S side. If I divide this by 2, these cancel, so I end up with 2 square roots of 3. I'll write that the right way this time. So my S of the Y side here is 2 square roots of 3. I'm going to put it inside my triangle. Does that make sense? Did everybody see that? Okay. Remember, the trick is when we're kind of do it is just divide. So never mind. Don't worry about that. That was not the right spot for this. So now we're trying to find the S square roots of 3 side. My S is 2 square roots of 3, so I end up with 2 square roots of 3 times the square root of 3 is what that's actually telling us. So this becomes 2 square root of 3 times the square root of 3 becomes square root of 9 because I multiply the numbers inside. This becomes 2 times 3, which we all know is 6. So that side becomes 6. Hope that makes sense. The other two look fairly simple to kind of figure out and get through. They actually look like the problems we did in class the other day too. So just kind of practice through them, make sure you understand them again, and you know what you're working on. Okay. Again, go through those. The answers will be posted with the PowerPoint. Word problem here. One of the displays of a botanical garden. They planted in the shape of a square. Square measures 6 yards on each side. We can view the yards on a diagonal path. They want to know how long this path is. So they're looking for this side, which is what, everybody? Hypotenuse. It's a square. So we know it's a 45, 45, 90-degree triangle because that's what happens when you cut a square on the diagonal. We also know that if x is 6, my hypotenuse is going to be 6 times the square root of 2. Does that make sense? Hope everybody kind of got that one. Okay, here's one I'm going to want you to kind of think about on your own. I know it's a little bit more involved than what you've seen. You can definitely do it. You're going to have to work through a fraction, kind of figure out what it is, but it's definitely something you can do. Again, there'll be a review with the answer, with all the steps you had to do to kind of figure it out. So give it a shot on that one. If you have any questions, send me an email. Area of a triangle, I think everybody knows that. What we've done here, though, is it's not just simple size shapes of a triangle. We've given you kind of different representation. What we're looking for is the area of the shaded region. So I'm looking for the area in here, not where the dotted lines are. The dotted lines are necessary to give us the heights and weights of what the triangle is, the altitudes, which we're going to need Pythagorean theorem sometimes to figure out based on information we're given. So again, when we kind of look at it, the base of my triangle here is 25. They're telling me over here that my height of my right triangle here, which is the altitude, the height of my whole triangle is 17. So we remember area of a triangle is 1/2 times the base, 25, times the height, 17. So I know 17 times 25 is 425. Half of that is going to be 212.5 centimeters. Does that make sense to everybody? Hope everybody got that. Again, try the other two. I'm actually going to do those here. So do those two, put your answers in that puzzle, and then come back and look at the answers. Again, they've kind of extended our triangle a little bit longer. We don't need this. That's just extra information I don't need. The area that I'm looking for is the shaded area, which is 1/2 base times height. This is my height. This is my base. So 1/2 12 times 20 equals 120 inches. Make sense? Again, we're just looking for the shaded area. Extra information I don't need. Area of my triangle is 1/2 the base times the height. Sorry, 8 is my height, not 12.8. Again, that was extra information I didn't need. I almost messed up there. So my height is 8. So 1/2 of 32 is 16 feet. Sorry, squared. These all should be squared. Make sense to everyone? Okay. Again, the last problem is a word problem. They give you some information. Area of the triangle is 242 square millimeters. They want you to find what the base and the height is based on what they've told you that the height is, or the base is 4 times the height of the triangle. So kind of draw a picture, put it in a little bit more algebra than you're used to, but it's something you can do. Again, the PowerPoint presentation will be posted with the answers later on today. Other than that, have a good day. Remember, tomorrow we're going to do another lesson. We're going to kind of go over special right triangles again, do some more problems, kind of cover some more stuff tomorrow to get us ready for the test on Friday and Monday. And then Thursday, there'll be a review packet for you guys to work on in class to get you ready as well. Have a good day.